Okay. Been having all kinds of issues with technology today. Hmm. Please be sure and sign in to chat. There are some people I've had that I'm currently getting up to date in my attendance records. In my what do you call it? My Excel spreadsheet for my attendance. I'm caught up on it, except for today. And but I haven't updated the attendance in ACES. There's an ACES attendance I'm supposed to keep current, and a Canvas also has an attendance thing in it that I keep current. So if you have not been signing in to chat every time you come to class, you will be counted absent. If you've been here and I count you absent, then please email me and we'll discuss the situation. I've had one person who has not signed in at all. And I have no idea what class that is in. I didn't keep track of that. And so they signed in maybe once and they haven't signed in ever since. So they'll show up as being absent, even though they may have been here every day. So just be aware that you need to sign in to be counted absent, to be counted present. Is anybody having issues with the YouTube channel? because I have at least one class who's having issues with it, maybe two.
Actually, the last class I'm gonna say that the the new videos that you upload, but you already upload on the.
Yeah, I'm up to date with all the videos. So that's one of the things I did this past week is get all the videos up to date. I think they were all up to date by Saturday, I think it was, by Friday evening. Actually, by Thursday, I think everything was updated Thursday. Except for my Thursday afternoon class. Okay. Then I will do this. And that is not what I wanted to share. I wanted to share this. And where is it? There it is. To get to the videos, in announcements, there should be that one of the announcements, it talks about YouTube video and it has the link there. Now, a lot of people have been doing that link in my other classes, and the link is bad. So that's an issue. Now, this is the review sheet that you should have in in Canvas. Yeah. You go into Canvas and you go into files and you go into exams and reviews. And there should be a folder in there called exam 1. So in files, there should be one of the folders is reviews, and under inside that folder is exactly one folder, exam 1. And in exam 1, there's exactly one document, and this is the document. Okay. Yeah. Please be sure and let me know if you're having any issues getting to the YouTube channel. Because if I need to create a new YouTube channel, I will. I already I had to create a new one for one class and re-upload everything into that one. And I have another class that's having issues with it, so I'm gonna have to recreate. It won't open. You get the monkey with a hammer. There's a, if it doesn't work, it'll say, oops, something went wrong. And there'll be a picture with a monkey with a hat on and he's holding a hammer. So that means I have to create a new YouTube channel. It's a pain in the butt to have to do that. But anyway, so yeah. Now for the exam is in Canvas. And under Canvas, there should be a menu item. It's not there yet because I haven't put anything in it, called quizzes. And in the quizzes, there will be exam 1 in there. And then you'll click that link and there'll be the exam. Now, all right, so some people aren't having issues with it where other people are. Okay. Yeah. Yeah, if you could post that link in the chat, yeah, so people can see if it works for them. Now, what I had expected people to do, which I know it's kind of silly for me to do it because most people don't, is you come to class having already worked this review. So you come to class with questions about, I need to know about this problem, or I don't understand how they got that answer. Or, and there's a gross typo on this problem, on this, I think it's number 45 or 42. I can't remember which one it is. Yeah, it's 45, where it says 4 to 3. It's supposed to be the interval from 4 to 3. Well, intervals go from low end to high end. A low bound, the lower bound to the upper bound. Well, with the lower bound being 4, the upper bound cannot be 3. The upper bound was supposed, that should have been a 7 there. And that's an error in the program that I used. So that should have been a 6. I'm sorry. 4 to 6. Because they're talking about from here to here, from this point down to this point, where it's decreasing. Okay. That was the only mistake I saw in this. Some of the things I want to talk about are how the questions will be presented on the test. All right. Numbers, I think 7 through 16. No, 9 through 16, I think it is. Yeah, 9 through 16. You will have one graph that'll look like this graph, except instead of going from -20 to 20, it goes from something to something else. All right, -5 to +5, or -200 to +200, both in the X and Y. So you'll have one question with that diagram on there, and then you'll have, I think, A through G or A through H. I don't know. And it'll be these questions, but for that specific graph. Okay. So you'll have that one, you'll have the one picture up here with the appropriate graph, and then you'll have letter A, B, C, D, E, F, G. I think it goes to H, but I'm not 100% sure. 1, 2, 3, 4, 5, 6, 7, 8. No, 7. There's 7 questions here. So no, that is 8. 9 to 16 is 8 questions. And so there'll be this will be like how the question will show up this way, and then you'll have a box below it where you type in your answers. And so you would type in the A and then write your answer, and then type in your answer, and then B and typing your answer, and C and typing your answer, and all the way down. So like that. And if you answer them out of a different order, then you can put them in the order that you answer them. Okay. It annoys your professor a little bit, but that's okay. You know, you can annoy me. I'm used to it. I taught freshmen for 19 years, so taught 14-year-olds for 19 years, so I can deal with it. So, and that's how most of this works, is you type in your answer. If you had to do work to get the answer, then you write down the work on a separate sheet of paper. So it's like working a test. So you have your worksheets where you do all your work, and you save those, because at the end of the test, you're going to come on, damn it. If you have a smartphone or access to one, there's a program called Adobe Scan. Some phones have it come into their phone. I have a Samsung phone, and it came with Adobe Scan. It's a free download. iPhones have something similar in it, or you can download the Adobe Scan. One thing it does is you take pictures of your work, and it turns it into a PDF file. And so you take a picture of the first page, and then you click add another document, and so it'll, or add another page. And so you take a picture of all your pages in sequence, or whichever order you want to. I had one person it was just willy-nilly. I'd hunt through to find out problems 1 through whatever on there. It was a little bothersome, but it's okay. I expect that to some degree. Don't everybody do that. And once you've scanned all that in there, and you save it as a PDF file, I expect to see anywhere from 4 to 6 pages. But I've had people where most people do 4 to 6 pages, he would do anywhere from 10 to 25 pages, and he would scan all those in and submit them. There's where you upload your submission, there will be an upload a button, or I'm not too sure what it was. I meant to look it up before I came to class today, but someone came to my office. And so and then there's a submit button, but you upload your files. And if you send it as one PDF file that has several pages on it, that's better than uploading each page individually. Okay, because sometimes they don't always get uploaded. If you uploaded one big document that had 4 or 5 pages in it, it will totally get there. Where if you upload 4 to 6 pages individually, one of them may not make it, or I may not see it, simply because of the way the program works in Canvas. And then you submit it and you're done. Okay. You will have till 5 p.m. on Wednesday to get me all the work submitted. But during class time, from 12 to 2 is when you type in all your answers. Okay. I need to see the work for the answers you get, because your answer is only worth 2 points. If the answer is correct, all I can give you is 2 points. If you don't give me any work. And if all you give me is an answer and it's a wrong answer, then all I can do is give you 1 point if you don't give me any work. You may have gotten the wrong answers simply because you added when you should have subtracted. Well, then that would have just been a -1 point, not a -9. So please, this is important, doing this. If you don't have Adobe Scan, okay, or in some way get a picture of your work and turn it into a PDF file, because that's the only way I want it to come up as a PDF file. PDF files are much easier to deal with than pictures or PIC files, JPEGs or whatever they're called. Okay. All right. The exam is this Wednesday. Yeah. I have the exam dates posted in, yeah, I think I did. Yeah, I did post the exam dates in the syllabus. And last Wednesday, I said that the exam was this coming Wednesday. So. Okay, from 9 to 16, are there any questions about this?
When we're showing the work for like questions 9 through 16 on the exam, do you want us to like separate each of the questions out, or can we just do like one giant graph and just kind of mark it all down?
Well, on 9 to 16, like on number 9, find f of -20. What work is involved?
Just looking at the graph.
Say again? I could barely hear you.
Looking at the graph.
Looking at the graph. How do you document that on a piece of paper? Yeah, okay. So on these types of questions, just putting down the answer. So what's the answer here? What is f of -20?
$10.
That's not 10.
12.
What each of these tick marks is worth how many?
Crap, I only saw 4. My bad.
Yeah, they go up by 4 each time. So and that's in either direction. It's either a +4 or -4 each time. So that's 4, 8, 12, 16, 20. And same thing this way, but then these are -4, -8, -12 on down. And same thing over here. So these tick marks divided into 5 equal sections. So divide 20 by 5, and that gives you 4. Each one of these is worth 4 units. And that's another thing on the test. This, if this is 200 to -200, 200, then each one of these is worth 40 points. So this one here is halfway between 12 and 16. So this is 14. The X value is 14. But what was the Y value here for this point?
12.
12. So that's all you would type in is 12. You would go, this would probably be letter A is 12. And then letter B, which would be number 10. So is f of negative 20 positive or negative? So you look at answer A, is that a positive number or a negative number?
Positive number.
Positive. This is probably the easiest question on the test, and I guarantee I'll get 2 or 3 people saying it incorrectly. Because they see that negative 20 and they assume it's going to be negative. No, what is f of negative 20? F of negative 20 is the y value, and the y value is positive, so that answer is positive. And then you move on to letter C. Okay. For which numbers is f of x 0? Well, those are the x-intercepts, right? Please realize that the graph you're given may not have these points signified the way they are here. I traditionally use the one that looks like similar to this one, where this point is not highlighted. It doesn't have a dot on it. This does not mean that you don't consider that point. You have to consider that point because it's an x-intercept. It's where f of x equals 0. So whether it has a dot there or not, we're talking about this point, and we're talking about this point, and we're talking about this point. So here they want those x values. So it'll be negative 12, 14, and 20. And then you move on. Now this one, it's going to be talking about intervals. So where is x greater than 0? Well, this one you can probably just draw it very quickly, just sketch it out. Doesn't have to be extremely accurate. It just has to kind of follow the same pattern as that one does, sort of like that, right? And from here to here, it's above the graph. And from here to here, it's above the graph. So that's what they're asking. What x values is it above the graph? Well, that the lowest point is 20, negative 20. And then here is the point, is this point. Well, and that's what? Negative 12 again. So from negative 20 to negative 12, it is above the x-axis. But what interval is that? Well, negative 20 is above the x-axis. So at negative 20, it is above the x-axis. So we do that. But at negative 12, it's on the x-axis. It's not above it. So we use the parentheses. This other interval over here is going to be open at both ends because both endpoints are on the x-axis. So it goes from 14 to 20, but it does not include those endpoints. So I put parentheses. And so what do I type online? I type interval negative 20 comma negative 12, and I just enter it that way. And 14 to 20 are the two intervals where it's above. So I just write down the two intervals it's above. Or if it asks where is it below, then in this case, there's only one interval where it's below. Right? How often does y equal 4 intersect the graph? Well, I look for where y equals 4. And it goes through right here, and that's 3 points. So it intersects. You can either type 3 times, or you can type just 3. I mean, it doesn't require much. These don't require much work. The only one that requires any amount of work is the number 12. For the domain, what's the lowest x value? What's the highest x value? So it's negative 20 to 20. Does it include negative 20 and 20? Yes. So it's going to be from negative 20 to positive 20, and it includes the endpoints. So this is our domain. The x-intercepts is the exact same answer as on this one here, and number 11. Number 11 and number 14 have the exact same answers, because the x-intercepts are the same as the x values that make the function equal to 0. The x-intercepts are the zeros of the functions. And y-intercept, that's right there. And then, well, typing right there isn't gonna cut it. You're gonna have to tell me what the y value for. So when they ask for the y-intercept, you can either give the point 0, -12, or you can give or you can just say -12 is the y-intercept, or just -12. Okay. All right, let me come back up here. Numbers 5 through 8. I will give you like something like y equals 3x plus 9. I mean, f of x and g of x equals a -2x plus, no, not plus, yeah, -2 plus 7. And then now, then there'll be a, b, and c and d. So what is g plus f plus g? What is f minus g? What is f times g? And what is f divided by g? What do these all equal? Well, this means I'm adding the two functions, so that's going to give me x plus 16. I'm subtracting this one, so I'm subtracting a -2x plus 7, which gives me a plus 2x minus 7. So that's going to give me 5x plus 2, because I'm subtracting the -2x and I'm subtracting the 7. Subtracting a negative is adding the positive. And then f times g is multiplying using binomial multiplication. So you're going to do 3x plus 9 times the -2x plus 7. And so you get a -6x squared, and that's going to be 21. That's a -18. So that's going to be plus 3x plus what? $63. And letter G is just 3x plus 9 divided by a -2x plus 7, where, and I need to stipulate that x cannot be 7/2, because our denominator cannot be 0. So that means a -2x plus 7 is not going to be 0. So a -2x is not going to be -7, or x is not going to be a 7/2. Okay. Oops, if I take the cap off. And then numbers 1 through 4, that's just putting the numbers in appropriately. 3 and 4. I like to put those on there, even though that type of problem is covered with even and odd. The main reason is when we start dealing with graphing polynomial functions, we want to know what f of negative x looks like, so we can use it in helping us graph. And it helps us in finding, determining if -1 is a 0 or not. And then knowing whether the function is an even or odd function is helpful as well. And so when we do f of negative x on letter F, we have 3 times a negative x squared plus 4 times a negative x minus 5. And we call that number, the minus 5, a constant, so it's not going to change. Squaring a negative number doesn't change the square, so 3x squared. 3 times a negative x being squared is 3x squared. And then we get a minus 4x, because 4 times a negative x is a negative 4x. And then the constant never changes. So this is what we're looking for here. F of negative x. We have one sign change. So that means this has exactly one negative root. And we have exactly one positive root. So this function has 2 real zeros. Now, whether they're integer or rational zeros or irrational zeros, I don't know. So they're probably irrational, because 3 times 5 is 15. And taking the negative into effect, the factors of 15 that subtract to 4, well, they don't exist. So at least not as integer values. So we would have to use the Pythagorean theorem to find the zeros of this. But anyway, no, the not the Pythagorean, the quadratic formula. All right. And this one would work much the same way. We would just get a negative x in the numerator and the denominator wouldn't change. So neither of these functions are even or odd, but it wasn't asking for that. Here they're asking for that. And so this is where you put the negative sign in, you put the negative x in for x, and determine, does it equal the original function? If it does, then it's even. If it doesn't, then you check to see, does it equal the negative of f of x? If it does, then it's odd. And if it doesn't do either one of those, then it's neither. Yeah. Now this okay. Oh, it goes down. I worked this one earlier, so I know where it's going. Okay, so on number 23 and 24 is done the exact same way. On number 23, how I look at this, we have it on the number line from 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's -9. So from -9 up to +3, we're going to use x plus 1. And once it becomes 3 and up to when it is 3, we use 6. So -6, 2, 3, 4, 5, 6. So I've already plotted 1 point on this graph, because when it is 3, it's the y value is -3. So notice I put a vertical line right here to tell me at 3 it's going to be down here. And so from -9 up to 3, but not including 3, we're going to use f of x equals x minus x plus 1. And then from 3 and bigger, so up to infinity, we're going to use the function -x plus 4. So when x is down up here, we're going to use -x plus 4. When x is down here, we're going to use x plus 1. And when x is 3, we're going to use -6. So this is the point 3, -6. Now, for these two intervals, I want to look at what happens at the endpoints. And because x plus 1 is the equation of a straight line, and so is -x plus 4, it's for a straight line, then I just need to find the endpoints, and then I can draw the line. When I put -9 in for x, that's going to be -9 plus 1, which is a -8. So I go at -9, I go down 1, 2, 3, 4, 5, 6, 7, 8, down to -8. And at 3, when x is 3, I'm not going to use this function, but as an endpoint, I can say that when x is 3, I get 4. And so at 1, 2, 3, 4, I don't put a closed dot, I put an open dot because it won't equal. And then I just connect them like that. And this is the point 3, 4. It is not part of the graph, but it's an endpoint. It shows what the function, what it's approaching, but once it reaches that x value, it drops all the way down to here. Now we want to do the same thing for this part. I want to put 3 in for x here, so I get 3, the negative of 3 plus 4, which is 1. So at 3, it's 1, but it's not on that point, so I use an open dot. Now I'm going to look and see what happens at 4 and what happens at 5. So I have 2 more points to graph. So I can draw that line. So when x is 4, I get the negative of 4 plus 4, right? Which is 0. So that's this point, 4, 0. And when I put 5 in, so that's going to be the negative of 5 plus 4, which equals a -1. So that's this point. So now I have enough points to be able to graph it over here. Put my arrow on the end. And I'm done. Now, when you have this question on the test, yeah, it'll show up something similar to exactly like this, but you can't download it to type on there and then upload it that way. This is all going to be in your work. So this is what I'll need to see. I'll need to see how you got the endpoints. I'll need to see all this stuff appropriately, graphed appropriately. Okay. And actually, since 0 is in this domain down here, then I would have gone ahead and put 0 in for X. So that would have been this point. So that tells me the y-intercept. If it has no y-intercept, I would include it. So putting 0, finding out where the 0 is in the domain, and then plotting that point. Okay. I'm not going to ask this, but this one it goes from -3 to 15. So that one, we're talking about it. It's going to start at -3 and it goes to 15, and it includes the endpoints, so it would be brackets. And noticing here that it goes from -3 up to -2, but not including 2. But once it hits 2, it's in this next interval. So 2 is a boundary point, and the boundary point belongs to only one of the 2 intervals. So it includes all the numbers for the entire domain. It's just the domain's been split up into 3 pieces. And that function, that graph would look weird as hell. Okay. Well, let's see what it will look like. Number 25. Number 25. Oh, that they didn't graph it. They were just looking at the domain. Oh, and they wrote it that way. -3 is less than or equal to X is less than or equal to 15. This is in set builder, and this is interval. Writing it either way is appropriate. Even just writing the inequality would be appropriate from my point of view. Okay. Running back up here, and we did. Now we're going to be looking at these a little bit. I'm just going to do number 26. So I always look at, we have the square root of x minus 2 minus 5 is our f of x. Our parent function is the square root of x, but we're changing our x value. We're going to change our x value. Whoops. There we go. So that means I'm changing where it hits 0. So x minus 2 equals 0 tells me how much I'm going to shift the graph. If I look at the original graph, 0, 0, 1, 1, and 4, 2, right? 4, 2, 1, 1, and 0, 0 are my first 3 key points on this graph. And so I'm going to look at what happens to each one of those. All right, so my change in the x is a +2, because here I get x equals 2. So I'm changing my X value. So that means 0, 0 got moved up to 2, 0. And that means 1, 1 got moved up 2 units along the X axis to 3, 1, because I added 2 to the X value 1. And I'm going to add 2 to the X value 4 to get to this point, 6, 2. And so now here's my new graph. Okay, so that's dealing with the X. That's dealing with the function, the square root function. Now we're gonna mess with the Y values. We only messed with the X values. Now we're gonna mess with the Y values by subtracting 5 from each Y value. So the 0 gets a -5. So that's 1, 2, 3, 4, 5 negative. So we go down to 2, -5. And then the 1 gets, I'm going to subtract 5 from 1. So that's a -4. And so 3, 1 comes down to negative. This one came down to here, and 3, 1 got brought down to 3, -4. And then the 6, 2, I'm going to subtract 5 from 2. So 6, 2 got moved down to this point down here, which is 6, -3, because 2 minus 5 is -3. So that one got moved down. And so now here's my new placement. Okay. So on the exam, it might be an X squared, it might be a square root. It's not going to be it's not going to be difficult. Okay. I like the square root because it's just these 3 points here. What am I doing to those 3 points? Where am I moving them to? Well, I moved them 2 units to the right and 5 units down. And I showed the shift. You could have done the -5 first and gone down to these points down here. Uh-oh. Oh, this one. Down to here. And so you could have gone to this first. So it would have gone down and then to the right. You wind up in the same place, but you get them going you either have to get on the other side of a building. You can either go straight and then turn, or you can go down and then go straight back. That so it doesn't matter. You wind up at the same place. So it's about where the grid points wind up. Okay. Oh, you will only have one graphing of a piecewise, and you'll have one graphing using transformations like I just did there. All right, numbers 28 through 33, you'll be asked to find the real zeros of, if any, of each of the quadratic functions using any method. And I will I will give you the quadratic formula in the question title, much like this one. And so you can either use the quadratic formula, or if you can factor it, use factoring. If you have 4x squared minus 25 minus 21, and we use the factoring technique I showed you the other day, where you multiply 4 times 21 and get 84. And so I want the factors of 84 that subtract to give me 25. So 1 and 84 don't work. 2 and 42 don't work because that gives me 40, not 25. And 3 times 28 gives me 84. And when I subtract, I get 25. So these are the pair I'm going to use. And so in using that method I used the other day, I used to call it the Berry method, but now I call it the Berry method, or the down under method, or the Australian method, where we put 4x and 4x. So I put the square root of x and square root of x squared in there, but I don't put the square root of 4. I put 4 in both places. Because I have an extra 4 in there, I need to divide 4 out of one of them. Now the two numbers that go in each binomial are 3 and 28. 3 and 28. Now, because the 21 is negative, these two signs have to be different. To get a negative 25, it has to be 3 minus 28. So the 3 is plus and the 28 is minus. And now this is what equals 0. Now I look to see, does 4 divide one of these quite nicely? Well, it does. 4 divides this one quite nicely. And so the 4x plus 3 remains the same. And then 4 into 4x is x. 4 into 28 is 7. So it's x minus 7. Now I have a product that equals 0. So I set each factor equal to 0. So I have 4x plus 3 equals 0. And then I also have x minus 7 equals 0. So one of these gives us our, so these gives us our zeros. Subtracting 3 and dividing by 4, I get x equals a negative 3/4. And then just adding 7 to both sides, I get x equals 7. So I have a negative 3/4 and a positive 7 as my zeros. Or I could have written as 7 comma negative 3/4, doesn't matter. Or I could have used the Pythagorean theorem. Pythagorean theorem is the negative of b plus or minus the square root of b squared minus 4 times a times c, all being divided by 2a. And that's what x equals. So x is going to equal the negative. All right, so A is 4, B is a negative 25, and C is a negative 21. So I want the negative of negative 25 plus or minus the square root of a negative 25 being squared. Squaring a negative is the same as squaring the positive, minus 4 times 4 times 21. And the whole thing is being divided by 2 times 4. So the negative and negative 25 is 25, plus or minus the square root of 25 squared is 625. That's one of the perfect squares, even though it's not one of the ones I originally talked about, the first 16 perfect squares. Knowing 25 squared is 625 comes in very handy because it shows up. Not a lot, but it does show up. Okay, and then we're gonna, oh, that was a negative 21, sorry. So a negative times a positive times a negative is plus a positive. And so 4 times 4 times 21 is 336. Yeah, that's what it is, 336. And how did I do that so fast? Because I've worked this problem previously. So I don't have some magic. What I did was I did 4 times 81 because 4 times 21, and then that's 32 plus 320 plus 16, which is 336. Oh, that was a 4 here. Now adding these two, we still have 25 plus or minus the square root of 900. Is that 61? Did I add correctly? And because this was done previously and someone in the class had a calculator, so this is 25 plus or minus 31 divided by 8. So that means I get 2 answers for X. One is 25 plus 31 divided by 8. And the other answer is 25 minus 31 divided by 8. 25 minus 31 is -6. So -6/8, which reduces to a fraction -3/4. Look familiar? And then this one here, 25 plus 31. That's 56, right? 56 divided by 8 is 7. 7. So we get the same 2 answers. Okay. Just realize that this method or any of the traditional factoring methods, if they don't work or you can't use them, then you have to use the quadratic formula. Okay. And there'll be 1 or 2, no, probably 2 problems dealing with that. And so if you want to use the quadratic formula on both of them, then go for it. If you want to try and factor them, go for it. Realizing if you can't factor them, you need to use the quadratic formula. Now, when they start talking about the vertex and the axis of symmetry and finding those things, there's one formula you need to know that I will not give you. This formula for the x value of the vertex also gives you your axis of symmetry. Whoops. Well, let me do it this way. So H is the x value of the axis of symmetry. I mean, H is the x value of the vertex. So that's going to be the negative of b over 2a. And k is the y value of the vertex. And that's going to be f of h. So you find out what h is, put it back in the function, and there you have the x and y of the vertex. HK. That's the vertex. And then the axis of symmetry is x equals h. X equals the x value. So we identify our A, B, and C. A, B, and C from the function. And so I'm gonna look at number, well, let's look at number 34. A is 1. B, is there an x term in 34? Is there an x term there? What is x being multiplied by if there's no x term? If it's, what are we always adding? What are we always adding? Oh, wait a minute. There is an x term on that one. There's another one that didn't have an x term, that our b value would have been 0. Well, here it's -6. And our c value, there's nothing being added there, but what are we always adding?
0.
Bingo. So I put 1 in for A, -6 in for B. So in this case, H is going to equal the negative of -6 divided by 2 times 1. This negative sign does not take care of this negative sign. I need both of them. Negative times negative is going to be positive. So this is 6/2, which is 3. So my axis of symmetry is x equals 3, and my x value for the vertex is 3. So now I'm going to put 3 into the function x squared minus 6x. So that's going to be 3 squared minus 6 times 3, or 9 minus 18, which is a -9. So the vertex is at 3, -9. And the axis of symmetry is x equals 3. So on the test, what you type in as your answer are these two things. So you say this is the vertex, and you say this is the axis of symmetry. Oops. Okay. Numbers 35, 36 are done the same way. See, on 36, the x value is 1. So the y value is going to be -7. So the vertex is 1, -7, and the axis of symmetry is x equals 1. Uh, 6 divided by 2 times 1, and it's going to be negative, so it's going to be -3. So on number 35, the y value is -3. Let me see, -3 squared is 9. So that's going to be -18 plus 8. So that's a -1. And so -3, -1, -3, -1, and then x equals -3 is the axis of symmetry. Yeah, I'm kind of going through these kind of fast. If you need me to slow down or explain how I'm getting certain numbers, please don't hesitate to ask me. I don't want you to walk into the test confused. All right, numbers 37 through 39. You'll have one or two questions similar to these. And yeah, okay. You're being asked to graph it. So finding the vertex, axis symmetry, and intercepts. Well, the vertex, so we have the negative of b over 2a. Right? A in this case is 1. And b is 8. So we have the negative of 8 divided by 2 times 1, which ends up being a negative 4. So I come back. So that's my h value, negative 4. That is also my axis of symmetry, negative 4. So I'm going to right away, 1, 2, 3, 4. I can graph that vertical line. And I graph it as a dashed line because it is it's a reference line. It's not part of the graph. Okay. Now I put negative 4 back into the equation. I get a negative 4 squared minus 6 times a negative 4. Oh, wait a second. Where did I get an 8 from? B is not 8. B is negative 6. I have no idea where I got that 8 from. Did anybody else notice that? So I wrote an 8 again. So that's negative 6.
For number 37?
Yeah, for number 37. Oh, 30. It is
Yeah,
8.
it is 8. Yeah.
It is 8. Okay. Oops. Mm. So it's x squared plus 8 times whatever x is. So I have a negative 4 squared and 8 times a negative 4. So this is a positive 16 and this is a minus 32. So that's negative 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to cheat. And since my graph didn't go down to negative 16, I'm cheating a little bit. And now I'm going to set x squared plus 8x equal to 0. I can factor x out of both of those and get x times x plus 8 equals 0. So x equals 0 and x plus 8 equals 0. So x equals 0. So 0, 0. And x equals a negative 8. 1, 2, 3. So that's right on the edge of my graph here. Did not plan this one out well, did I? And so there I have it. Yeah. I should have planned that one better. Come on. Be nice to me. So this next one, x squared plus 2x minus 8. A is 1, B is 2, C is a negative 8. Right. I always gravitate towards my C value at the very beginning. 1, 2, because that tells me where it's going to cross the x-axis. I mean the y-axis. I didn't realize I didn't write it on there. Okay. So H is the negative of B over 2 times A, which is the negative of 2 divided by 2 times 1, which gives me a negative 1. So at negative 1, I have a vertical asymptote. X equals 1 is my vertical asymptote. When I put negative 1 back into the function, I get a negative 1 being squared plus 2 times a negative 1 minus 8. So that's a positive 1 minus 2 minus 8, which gives me a negative 9. So that's this point here. If I do the symmetry thing, then that means this point is on the graph. If I set 2x, not 2x, if I set x squared plus 2x minus 8 equal to 0, that will give me my two y-intercepts. So since the leading coefficient is 1, then I'm going to have two binomials, both with x's at the beginning, and then the numbers that go here and here will be the factors of 8 that subtract to 2. Well, that's going to be 4 and 2. 4 times 2 is 8. 4 minus 2 is 2. And 4 minus 2 is a positive 2. So that means the 2 is negative. The 4 is positive. Now I have a product of two things that equals 0. So I can use the zero product rule and set each factor equal to 0. And those two factors contain my zeros of the function, the x-intercepts. And so the first one gives me a negative 4 for x, and the second one gives me a positive 2 for x. So it goes through negative 2, negative 4 on the y-axis, on the x-axis, and it goes through positive 2 on the x-axis. If I look at the symmetry with respect to the line of symmetry, they are both 3 units away from that x value of negative 1. So we did that correctly. And here's the graph. It should go through this point and that point. Okay, questions? Reason I look over there when I ask are there questions is because that's where my Zoom picture is. Yeah, the camera's going down this way. All right. So that's how 30, 37, 38, and 39 are conducted. You'll get one, maybe two questions on that. Numbers 40 and 42, you might get a question out of that. So we're going to be looking at y equals a times x minus h squared plus k, where h and k are the x and y for the intercept, for the vertex. So the vertex on number 40, we get a times x minus a -1 being squared plus 4. Right? If it was a -4, then this would be -4. Simplifying in here, I get a times x plus 1 squared plus 4. And so right now, this is all I have to go by. Except I know the point 0, 3 is on that graph. So I put 0 in for x and 3 in for y, and I get 3 equals a times 0 plus 1 squared plus 4. 0 plus 1 is 1, 1 squared is 1, 1 times a is a, so you get a plus 4 is what 3 is, so subtracting 4 from both sides, a is a -1. So this function here, I replace a with -1, and it's going to be y equals a negative. Well, I can write -1, or I can just say the negative of x plus 1 squared plus 4. You could multiply it all out and say this is the negative of x squared plus 2x plus 1 plus the 4 here, and then change all my signs in there and say this is a negative x squared minus 2x minus 1 plus 4, or we get a negative x squared minus 2x plus 3. And so this or this are acceptable answers. You can stop here, or you can continue on. Whoa, whoa, whoa. Or you could stop here, or you could continue on. Either way, if you complete it out to here, you simplify it and write it in quadratic form. I might give you a point or two. All right, just looking at these two on numbers 42 and 43, you can tell whether or not they are have a maximum or a minimum. If A is positive, then it has a maximum. A minimum. If A is negative, then it has a maximum. And then you find out what they are by finding out what the vertex is. And so that's, yeah, we've already done that. Numbers 44 through 48 you'll get a graph similar to 48, and you'll be asked all these questions. How I deal with increasing, decreasing, or constant, I will I will drop a question like this. I will drop a graph similar to this on the test, and I will ask for where is it increasing? Where is it decreasing? Where is it constant? And then list any local maximums or maxima, and list any local minima or minimums. All right. And I will state somewhere on there that even though it doesn't show arrows at the ends, assume there are arrows on the ends and that the function continues on. Because if there's not, the way this program operates that creates these things, if it continues on, they don't do anything. They just stop. But if it includes this as an endpoint, see like here, and it includes these endpoints, so that means it stopped. Where on this one, it continues on that way and continues down that way. So, well, this said on 44, but assume the graph continues even though there are no arrows on 44, and also here on 48. And so it's increasing. Well, I as I go from left to right, what's happening? From negative infinity up to -8 on the x-axis. So from negative infinity up to -8, it was increasing. And then another place it's increasing from negative 2.5 to a positive 2.2, negative 2.5 to positive 2.2. No, it was increasing there as well, negative 2.5 to 2.2. It was increasing. So it's increasing in those two intervals. Now for decreasing, it's decreasing in two intervals from -8 to -2.5. The function is decreasing, and another interval where it is where it's decreasing is from 2.2 to 5. Whoops. Oh, and I missed an increasing interval. We have 3 intervals where it's increasing, and it's here it goes from 5 to infinity being increasing. Whoops. Okay. And nowhere is it constant, so none. There are no intervals, so we have none. Or you could say no intervals, or it does not have any, is constant nowhere. Local maximum. So where are the hills? The hills are at -8, 5. That's one top of the hill, and another top of the hill is 2.5, 2.2. Uh, 3.9. And then local minima, I have one at, and that's the bottom of the valley, so that's 2.5 and a -3.5, 3.3, sorry. And then the other one is at the point 5, -2.5. So there are a number of ways of stating these. You can list the points where saying these are this point contains a local maximum, this point contains the local maximum, and etc. with the local minimums. Or you could say it has a local maximum at 5, local maximum of 5 at x equals -8, and a local maximum of 3.9 at x equals 2.2. And do the same thing with the minimums, either way. Okay, I've gone through the review. I didn't cover every problem, but I covered what I expect to see when you're doing these. These two are the local maximums. This one's a local minimum. These two are local maximums, and that one's a local minimum. From 0
So I
to
have a
3, it is
question.
being, yes?
For the increasing and decreasing for the intervals, we put parentheses, right? We don't put any.
Well, because the textbook uses brackets, I'll accept that. But it's just realize technically it's wrong.
Okay, I was just making sure because I don't want to put something incorrect and then
Yeah,
get it.
well, I take into consideration what the textbook is telling you. I'd prefer you to put it the correct way, but on a test, and do it their way in MyLab.
Okay.
I know it's confusing, but you know, the devil gets his due. But I won't penalize you for having to learn to do it the incorrect way. Okay, what was I gonna? Oh, the exam itself. Okay, that's the thing I was going to talk about. So I'm going to stop this share and go to a different share. No, I'm not going to do that. Whoa, I didn't mean to do that. Go away. Okay, what I meant to do was this. All right. What the hell? Oh, I know why. Because another program was using the camera I wanted to use, and so it wouldn't let me show this. Okay, pin my screen, and so it should dominate your screen. And okay, so on Wednesday, you go to Canvas, you go to Zoom, and you put your face in the screen. You turn it on. You turn on your camera so I can see your face. And I don't mean when I want to see your face, I want to see the top half of your head and the wall up behind you. I want to see your face and possibly your shoulders. So I want to see a profile picture of you in the screen. Okay. And once you're in Canvas and once you're in Zoom and you have that up and running, then you go to back into Canvas and find quizzes. It'll be a menu item pretty close to where Zoom is. It's not there now because I don't have any exams in the quizzes. And once that pulls up, there will be a menu item. It should be called exam 1, but it'll be the only one there. And you click on there and it gives you all the information you need to know to take the exam, which is pretty straightforward. You put your answers, if possible, except for the graphing ones, you put your answers there. So for number one, you would list your answers, and number two, you would list your answers, and on down the line. And if it's a graphing one, you don't have to worry about putting an answer there. Don't worry about the grade you get in Canvas for the test. That's not the grade. The grade is when I look at your work. Now, did I already talk about taking a picture of your work? This is the third time for me going through this explanation, so I don't remember if I said this to for y'all or not.
Yes, you did.
I did. Okay. Where you can use a program called Adobe Scan. It's, let me see. Let me get my phone out. I should have done that in my other classes. I did not do that. Be done, be done. Shut up. All right. So I have this. This is my lovely phone. Here's my Rabbit Mew, which is my calculator. Oh, I need to find. There's Adobe Scan right there, dead and center. And I hit that and take pictures and record video. Okay. Yeah, allow it because I want to take a picture. And so I take a picture. What? Hold on. Yeah. No. Okay. I'm not doing that. Leave me alone. And then that's one picture. And then I take another picture. And then see. And so I took two pictures, and that tells me that I have two documents in there. And then and once I've taken take pictures of all my work, then I hit that, and then I can go through and preview what I've hit in, and I can possibly edit it, crop it, or if I need to. So, and then I can save as a PDF file, so it's saving as a PDF file, and then I have that to upload. Okay. And it tells me Adobe Scan September 20, 2021. So that's the one I look for when I want to upload. And so what I would do with this is I'd email it to myself and then save that on my computer and upload from my computer rather than my phone, because I find it easier for me. It's easier to do on my computer than from my phone. Because it's easier for me to find the files. I can't always find the files in my phone. So when I have them, I upload them to my computer. And then that's what you do when you're asked to submit. Come on, damn it. Being very incompetent right now. I can't put a cap back on a bottle. All right. Y'all have any questions? Oh, good, that's my face. All right. All right, please go in and see if YouTube is working for you. I have some people who the YouTube isn't working for, and email me, and I may have to create another YouTube channel. I'm already having to create one for 2 classes so far today. Yeah.
So for the test on Wednesday, we have to stay on Zoom with the camera on the whole time we take the test.
Yes.
Okay.
I didn't give you my cheating speech, and I should. I had some wholesale cheating going on through Zoom last fall, and I was partly to blame because I didn't push being on camera all the time. And I had a number of students whose work was exactly the same on some of the problems. And on some of the problems, they were close enough where the mistakes were copying someone else's work incorrectly. So I could track who was doing the cheating and what the cheating was going on, but I really couldn't prove it. And so what I'm doing now is, if I suspect you of cheating, I'm going to take points off until you prove to me that you weren't cheating. Okay. So yes, I will accuse someone of cheating who was not cheating. So we have this conversation and it's all taken care of. So that's what I want to have happen. All right. I know I'm about the procedures, and as long as the procedure's correct, I'm not having much problem with it. But there is some differences in how people do the procedures and the order in which they do the procedure. So yeah.
Okay.
So that's one thing that helps with it, is that if I can see your face, or like have the camera like this, so I can see that you're working here, you aren't grabbing your cell phone off to the side and doing work down here to Google the answer or whatever. So I need to see enough of the workspace so there's no question. And I will record that meeting so we can discuss it. If I suspect there's cheating and there hasn't been, then there won't be a problem. Okay. Any other questions? Because we're past time now. No, we're at time. Okay. I thought we were over. Any other questions or anything anybody might have?
I just wanted to say that the monkey appeared to me on the YouTube channel. I don't know if it's a problem or.
Yeah, okay. That means I'll go ahead and create a new YouTube channel. I don't know what the hell's going on, but it seems to be going on wholesale, not just. I don't know. It's just very frustrating for this to be happening. Yeah,
Actually, the other day was pretty fine, the YouTube channel, but I click it again and appear me the monkey, and it's pretty weird to happen that. So that's what I'm asking for.
it wasn't doing it the other day.
No, it was doing the other day, like 2 weeks ago, when I was looking for some research on the and recapping the issues that I have on math. So
Okay, so the other day it was working fine,
yeah,
but today it isn't.
yeah. Today I check again and like the monkey appeared and say something went wrong.
Then that might be a YouTube issue, not mine.
Oh, okay.
But well, I don't know. Let me.
Do you have the link for probably is the link?
Let me see.
Because
Where-
I used to take the link from the announcements.
Yeah, that's what I'm gonna do. Yeah, these should be working fine, and it's not. Let me see here. Let me go through YouTube Studio, the Creator Studio. Let me go to this channel for this class. And let me come back to the Zoom and find the chat and go bingo. Let's see, how's that work? Go ahead and click that in the chat. Whoops. Sorry, Miss Kennedy, I just posted it to you, not everybody. All right, there we go. So
Thank you, sir.
does that work?
I'm checking Charlie.
It's working for me now.
Yeah, it works for me.
Okay, so this one is working, the one in announcement isn't working, is what you're telling me, right?
Yeah. Thanks, sir.
Okay.
I already have the YouTube channel. Thank
So I'm gonna see, if you need to go ahead and go. I'm going to see. I'm gonna edit the announcement to see if it'll. It's the exact same thing.
Yes, sir. Does the link on the announcement say studio?
No.
Oh, okay. 'Cause
So what I did now is it's no longer an active link. You have to copy and paste.
this link works for me. Have a good day, sir.
Okay.
Professor Reed.
Yes.
Hey, it's Corey. So on Wednesday, unfortunately, I wouldn't be able to do the exam for the wedding. I'm free like tomorrow evening and all day Thursday. We did have a small conversation about this last week, but I just wanted to make sure that to let you know.
I'll send you the link, the Zoom link for my, well, can you come in at 8 o'clock on Thursday?
In the morning Thursday, like
Yeah.
into the college or into the Zoom?
No, into Zoom.
That should be fine. I'll have to set an alarm though.
Okay. So it starts at, well, that class is a 2-hour class. So but you'll have a time limit on yours.
That's
so
fine.
you come into the Zoom, but you still go to your class for the other
For the
thing.
exam?
So yeah, for the exam.
Okay, so I pretty much log into Zoom that way. You can just keep an eye on it, and then I do my questions during that time within the time frame of the.
Yeah.
Okay.
Well, your test will have a timer on it.
Yes.
And so the timer will tell you how much time you have left. So you'll have an hour and 45 minutes. I give an hour and 45 minutes on the test. So you have that 5 extra minutes. And then, but most people take about an hour and 20 minutes taking the test, not the hour and 40 minutes. So there are some that have to run up to the end, but it doesn't matter how many questions you have on the test. They have to take the entire time or run over. You have 10 problems and it should be done in an hour, and they'll still take the hour and 40 minutes. So I don't know,
I gotcha. Okay,
But-
but I'm sorry, cut you off.
No, go ahead.
So yeah, just send me that link. I'll be there first thing like 8 in the morning.
Okay, email me later today, so
Will
that
do.
reminds me. Either, it's best to do it at both in ACES and in the Canvas emails.
Through both,
Um,
like,
Or just do it in the Canvas emails, just remind me and I'll go ahead and set it up.
okay.
And I'll email you the link to that class.
Gotcha. And then one quick question. So when we're doing like when I'm doing the exam, I'm using most of my phone for Zoom. So with that,
Oh, that's
Is
gonna be
there-
difficult.
yeah. So because I don't have a
Can you still do you have a computer? You can still get in and do it?
I have a computer, but
But
I
well,
can-
you can do the Zoom separate from the computer.
well, yes,
You can
that's
do
like,
the Zoom for the picture and then do the computer for the exam.
okay, gotcha. So that's not gonna worry you at all in terms of the
No.
cheating and all that.
No, as
Okay.
long as I can see what you're doing, like I can see all my
Yeah,
arm movements here. Yeah.
sounds good. Okay. Thank you,
And
Professor.
then I'm aware of the fact that the video is coming from a phone and you're working on the computer.
Understood.
Okay.
Thank you, Professor. I'll see you later.
All right. Take care.
Sir, I got two questions.
Yes.
One is, will you be able to upload this video on YouTube today? Because
Yeah.
that'll be really useful for me because I wasn't able to digest all the information you gave us in that one try.
In
So I kinda wanna
about
go
20
through-
minutes, they'll send me an email saying that the videos are ready. And so I'll be able to upload it. And so I have nothing to do this afternoon except sit here and get things ready for Wednesday and Thursday.
All right, cool. Because that'll be really, really useful for me for the review.
Okay.
And second, I need to remember. Oh yeah, you might. I'm gonna start studying a bit the whole review. So you might expect me on office hours. Just a heads up, maybe.
Okay.
That's a maybe. Just so you know.
And that's what I'm there for. Yeah.
All right. Thank you, sir.
All right.
Bye.
Bye-bye.
Have a good day.